This video is on the very basic of screening air dispersion model SCREEN3 with respect to ScreenView software from Lex, the leader in air dispersion modeling software. First, we have to know what is air dispersion model. An air dispersion model is a set of mathematical equations that uses information about emission sources of air pollutants and meteorological conditions to calculate how a pollutant moves through the atmosphere and what the pollutant concentration is at specific point. So what is ScreenView? ScreenView is a user-friendly interface for the US EPA screening model, which is known as SCREEN3. It is a single source Gaussian plume model which estimates maximum, that is worst case ground level concentration for point, flare, area and volume sources, concentration in the cavity zone, concentration due to inversion breakup and shoreline fumigation. The SCREEN3 is a simpler version of IS3, uh, and the IS3 is used to assess air pollutant concentration from a wide variety of sources associated with the industrial complex, whereas SCREEN3 is a single source Gaussian plume model. Skin view can model scenarios with simple or complex terrain, with or without building wash, and give result at discrete and automated distances, having saving time and resources while eliminating the needs for more complicated modeling. Now, how to download and install screen view? We have to visit this page and hit this download option. This is a freeware, and follow the installation steps and enjoy screen view. Now we have to look the interface of screen view. So you can see the menu bar, toolbar button and input windows, the source type, dispersion coefficient, flagpole receptor and the point source parameter. One by one I discuss about the input windows. So the source input, the source type. So there are basically four types of sources: point, flare, area and volume. Localized source such as stack is example of point source. Flare is a localized point source where a high release heat rate occurs, such as flares. The example of area source is landfill, and the volume source is storage pile. Now we will discuss about the dispersion coefficient. So there is two type of dispersion coefficient, urban and rural. Now how to determine the dispersion coefficient? There are two methods. One is land use procedure and second is population density procedure. So land use procedure, if the land use types, that is the built up area, commercial, industrial and residential account more than 50% or equal to 50% of area of interest, that is within a 3 km radius of the source, then it is urban. Otherwise rural options have to be opted. And another is population density procedure. If the average population density is greater than 750 people per square kilometer within the AOY, then you can select urban options. Otherwise use rural dispersion coefficient. However, we recommend always land use procedure. Now source parameters. So depending on the source type, the source parameters will vary. So this is the source parameter of point sources, this is flare sources, area sources and volume source parameters. Now the flagpole receptors. A flagpole receptor is defined as any receptor located above ground level, for example, the roof or balcony of the building. So you have to give the receptor height here. So by default, the volume value is assumed to be 0, that is ground level receptor. Now, a terrain options. There are three types of terrain: simple terrain, complex terrain, and the combination of the both. The simple terrain options, if you select, then it is further categorized into flat terrain and elevated terrain. And for both of the simple terrain types, there are two distance options model: automated and discrete. So we must select at least one. Both can be selected, however. Now the options, there are two options applicable for point and flare sources, fumigation, building wash. However, both are optional. So this is only applicable as point and flare sources as told earlier. But in case of fumigation, the option is further applicable for stack height is greater or equal to 10 meter, and the dispersion coefficient will be the rural. Otherwise, this become inactive. Now we discuss about the simple terrain. Simple terrain, we know there's two options of modeling. One is simple flat terrain, and another is simple elevated terrain. So this is the stack base. So if the terrain height are assumed not to exceed stack base, is called flat terrain, and if the terrain height exceed stack base but below the stack height, here you can see that the terrain height exceed stack base but it is below the stack height, then it is called the elevated terrain. So these two options are available only for point and flare sources, and if the simple terrain or simple terrain plus complex terrain option is selected in the summary panel. Now this is the complex terrain. The complex terrain tab is available only for point and flare sources, and if you have selected complex terrain or complex plus simple terrain options in the summary panel. Complex terrain option should be used for cases where a terrain elevation exceed the stack height. So you can see that this is the complex terrain, because the elevation, this is the stack height, and the terrain is above the stack height. So then if the complex terrain is selected, then we have to specify the following parameters from the complex terrain discrete receptor distance tab. So we have to give the terrain height above stack base, and then specify the distance from the sources, and the downwind distance from the nearest terrain further likely to experience plume experience. So screen uses a receptor height above ground is 0 meter, that is no flagpole receptor in the complex terrain options, even if a non-zero value is entered. The original receptor height is saved for later calculations. So when complex terrain is selected from the summary panel, all other options that is simple train, different options, and distance options and other options will become inactive, that is need not to specify. So now we discuss about the meteorology. You can see that meteorology tab displays three options. One is full meteorology, second is single stability class, and single stability and wind speed. Single stability class and wind speed. Now we discuss about the first option, that is full meteorology, all stabilities and wind speed. All the meteorological combinations between stability classes and their associated wind speeds are considered to identify the worst case meteorological conditions, that is, the combination of wind speed and stability that results in the maximum ground level concentration. The wind speed and stability class combination used by the screen model are given in the following table. So you can see that Pascal and Gifford stability class, there is 6 stability class, and the wind speed is given. So this is the range of wind speed for each stability class, and there is the value, and for class A means it is very unstable, class B is unstable, class C is slightly unstable, D is neutral, E is slightly stable, and F is stable. So we have to, if when we use this class A, B, C, D, then this always have a range of wind speed. There is always a range of wind speed. So the second option is single stability class. This option considered the range of wind speed for a specified stability class. So you can select the stability drop down list, stability class. So if we use this, so this option, and if from here you have to give one of your stability class, that's all. And for the third option, that is single stability class and wind speed, these options allow you to consider a single stability class and wind speed combination. Select a stability class from the stability drop down list and enter the value. So from here, stability class, and enter value of the wind speed here. This is automatically selected based on that. So the wind speed value should fall within the range of the specified stability class. This wind speed range will be displayed automatically and can also be determined from the table shown in the earlier slide. So generally we recommend recommend full meteorology options, because the other two options may be useful when particular meteorological conditions are of concern, but not recommended for routine uses of screen. So this video may go long, so keep patience. Now meteorology overall, for the complex terrain options, screen automatically uses stability class E or F for rural and urban dispersion coefficient respectively, and the wind speed is of 2.5 meter per second for the meteorology of complex terrain. So in the complex terrain, so if urban dispersion coefficient is selected, then the stability class will be the E, and wind speed this 2.5 meter per second at stack height, and if the stability if the dispersion coefficient is rural, then the stability class will be F, and the wind speed is same. So this is the meteorology for the complex train. Now we discuss about the non-regulatory options. Two non-regulatory options is there. One is brought to mixing height. So you can choose to use this option or not by selecting yes or no. So if yes is selected, then brought to mixing height algorithm will be applied. We will discuss it later. And second is anemometer height. Anemometer height is the height above the ground at which the wind speed is measured. The default value is 10. However, you can choose to specify an alternate height here, but this option is not applicable for the third option of meteorology, that is single stability class and speed. So what is brought to mixing height? When the airflow meets a building or an obstruction, it is forced up and over the building. On the lee side of the building, the flow separates, leaving a closed circulation containing lower wind speed. Further downwind, the air flows downward again. In addition, there is more shear and as a result more turbulence. This is turbulence wake zone. If a plume gets caught in the cavity, a very high concentration can result. This is cavity. If the plume escapes the cavity but remains in the turbulence wake, it may be carried downward and dispersed more rapidly by the turbulence. This can result the dispersion of the effluent plume vastly different from that without the obstacle. This effect often results in an elevated plume being brought to the ground rapidly and is referred to as building downwards. Building downwash concept, where the presence of building forms localized turbulence zones that can readily force pollutants down to ground level. So the brought to mixing height option calculates a mixing height that is calculated based on the calculated plume heights, the anemometer height, wind speed, and a stability dependent factor which is compared to a stability dependent maximum height. So this algorithm uh, is expressed where Zi is 300 meter for A, 100 meter for B. So this depend on the stability class. uh, Zi mean, sorry, and Ji is the is the stack height, and HA is the effective plume height, and U10 is the horizontal speed on a level of 10 meter above surface. Now automated distances. This option is for modeling with simple train and with complex plus simple train. Automated distance give you the option of using pre-selected array of 50 distances ranging from 100 meter out to 550 kilometer using the following increments. So 30 plus 14, 44 plus 5, 48, and this two. So this is the 15 array. The first 30 is 100-meter interval, then 500, 5 kilometer, and 1000. So for the automated distance option, the screen model calculates the maximum concentration across the range of meteorological conditions for the minimum distance given. So screen then computes the concentration for each distance in the array larger than the maximum and less than or equal to the maximum. The automated distance tab vary depending on whether flat or elevated terrain are selected from the summary panel. So in case of flat terrain, so we have to put a minimum distance and a maximum distance. Minimum distance should be the distance to the plant boundary or fence line. The smallest value is allowed to 1 meter, and the maximum value would be the 50 kilometer. But for the area sources, the minimum value is 0 meter, and the largest value is 50 kilometer. Now elevated terrain. The terrain height above stack base. This is the height of the terrain above stack base. So we have to give this terrain height above stack base. So this value should always be smaller or equal to the effective stack height. Terrain height above stack base. So this is stack base, but this value should always be smaller or equal to the effective stack height. So this is the stack height. So this value will be the less than this stack height. And the minimum distance should be correspond to the minimum distance to the plant boundary or free fence line. The smallest distance is allowed 1 meter, and the maximum distance is the 50 kilometer. So once the automated distance are specified, click here the terrain height viewer button to view the automated distance that I have specified. For discrete distance, options is for model with simple terrain and with complex and simple terrain. So this option allow us to find the maximum impact at specific location of interest, such as nearby residence, hospital or schools, and may also be used for long range transport estimates out to 100 kilometer. So any number of distance can be input, and the maximum concentration for each distance will be calculated. However, we can identify the maximum of 15 discrete distance, that is the location of interest 50 can be given here. So these options find the maximum impact of the specific location. Distance source flat, the smallest distance is 1 meter. However, for area source it is 0 meter and maximum value is 100 kilometer. So you can use this add button there. So screen model will accept distance out to 100 kilometer for long range transport. However, for distance greater than 50 kilometers, screen sets the maximum 10-meter wind speed at 2 meter per second to avoid unrealistic transport times. Now we discuss about the discrete options for elevated train. So this is the height of the train above the stack base. So this is the train above train height above stack base. This value should be always smaller or equal to the effective base height. So this value is should remain within this range. However, if you put any value uh, outside of this range, then an error message, uh, uh, an alert will generate if the height you enter is out of the valid range. So the smallest value allowed is 0 and the maximum value is 100 kilometer. Once you have specified the discrete distance, click at this train height viewer button to view the discrete distance that have specified. Now the downwash. Downwash occurs when the aerodynamic turbulence induced by the nearby buildings causes a pollutant emitted from an elevated source to be mixed rapidly towards the ground, that is downwash, resulting in higher ground level concentration. The downwash tab is available if the building downwash box is checked in the summary panel. This option is only applicable to point and flare sources. This option is only applicable for modeling with simple terrain and with complex plus simple terrain. Defining buildings is straightforward as only one building requires definition. So only one building requires definition and following inputs have to be given. The building height, that is physical height of the building structure, then minimum horizontal building dimension and is maximum horizontal building dimension in meter. But to use this Salman-Serre algorithm, check this box here and then specify the position of the source of the building with respect to A and B building dimensions value. So give this and this here. And the next is fumigation. It occurs when a plume that is originally emitted into a stable layer is mixed rapidly to ground level when unstable air below the plume reaches plume level. The fumigation tab is available if the fumigation option is checked in the summary panel, and this option is only applicable for point and flare sources if the stack height is greater than or equal to 100 meter and the rural dispersion coefficient is selected. So the shoreline fumigation options can be specified in the fumigation tab, and the option is only applicable if the source is within 10 km onshore from the large water body. So the shortest distance from the shoreline we have to give here. The fumigation algorithm ignores any potential effect of elevated terrain. So if the shoreline fumigation option is selected here, in addition to the maximum inversion breakup, fumigation concentration and distance, maximum concentration and distance to the maximum associated with shoreline fumigation will also be available in the output file. The nearest distance from the shore to the shoreline in meter is to be given. If shoreline fumigation option is not selected, only the inversion breakup fumigation calculations are done. No further inputs are needed, and the maximum inversion breakup fumigation concentration and distance will be available in the output file. So I made this video by reading the documents mentioned under reference here and experiencing screen view software. So you can read those documents for more clear understanding. In my coming videos, I will you will be experiencing the output of uh, screen view features and screen view functions.